When we analyze a stripping column to determine the number of stages, we look at a plot on a solute ratio. That's on the y-axis is for the gas phase, x-axis is for the liquid phase. And we have two lines. This line is a mass balance, and this line is the equilibrium line that relates liquid and vapor phases that are in equilibrium. And this is Henry's law, so it's a straight line because we're at low concentrations. I've shown a diagram that represents 5 stages in a stripping column. And the notation, notice that for any stage, the flow leaving, so the liquid leaving has a mole fraction x3, the vapor leaving has a mole fraction y3. So the leaving values of mole ratios, I should say, are the same as the notation, the same as the stage number. And so if we were to write a mass balance, and let's write a mass balance around these stages, then the entering y3 times the gas phase, molar flow rate, plus x0 times liquid, that's what's entering, and what's leaving, y1, again, times the gas phase flow rate, x2 times the liquid phase flow rate. Well, this is stage 2, so you can see in general this is yn plus 1. This is still x0. The idea is we could pick any set of stages 1 through 4, for example, and do the same type mass balance. And if we do that, and so this is xn times L. So if I rearrange this, I have the general mass balance. That's the equation for this line. And so for now going to analyze, we start with these values. So for this equation, if I had n equals 0, then y1 and x0 would be on that mass balance line. So point 1 corresponds to x1 and y1. So they're equilibrium. Those are the values leaving stage 1. So they're on the equilibrium line. And now if I were to draw this vertical line, this corresponds to x1 and y2, right? So x1 we already knew from this point, and y2 because y2 is equal to L over V, x1 minus x0 plus y1. So x1 and y2 are on the mass balance line. So that's here where we have the mass balance. Drawing horizontal line, this point 2, x2 and y2. So that's the equilibrium line, the values leaving stage 2. That makes this point x2, and it must be y3 because of the mass balance. So we can continue to step through this way, and the reason we're doing it that way is because we're satisfying the mass balance, and then we're satisfying the equilibrium expression. And this is how then we can count stages in a stripping column.